Now that everything's connected, let's go through how to actually dial in your fermentation temperatures using your Glycol system. This is where you get real precision and repeatability in your process. The controller is cycling the solenoid and the pump, not the chiller.
The system controls fermentation temperature by cycling the pump. The Glycol stays cold in the chiller and only circulates through the jacket when the controller calls for cooling. When cooling is called for, the controller powers the pump and opens the solenoid valve, allowing Glycol to flow through the jacket. When the set point is reached, the pump shuts off and the solenoid closes, stopping flow. This gives you stable, controlled cooling without needing constant circulation. The onboard controller on the chiller manages the Glycol temperature. This does not control fermentation directly. It simply keeps the Glycol at your target temperature so it's ready when cooling is needed. The external temperature controller is what actually controls your fermentation temperature. You'll set your target temperature and a differential. When the temperature rises above your set point, the controller activates the pump and opens the solenoid, circulating Glycol through the jacket. Once the temperature drops back down, it shuts the system off. For exact button functions, refer to the controller manual. The differential determines how much the temperature can rise before cooling activates. A smaller differential gives tighter control, but will cycle the system more frequently. A larger differential reduces cycling, but allows more temperature swing. A good starting point is around 0.5 degree to 1 degree Celsius. The Glycol temperature should be set lower than your fermentation temperature. A typical range is around -2 to -4 degrees Celsius. Colder Glycol increases cooling capacity, but if it's set too low, you can overshoot your target temperature. This is not an instant system. The temperature will change gradually as cooling is applied. You're balancing Glycol temperature, set point, and differential to get stable control. The system is designed as a cooling-driven control system, meaning we're removing heat as needed rather than trying to heat and cool at the same time. For this setup, we recommend running cooling only. Adding heating at the same time can cause the system to fight itself, causing cycling between heating and cooling, which leads to instability. With proper Glycol settings, cooling alone gives you very consistent fermentation control. The solenoid valve is installed on the supply side and opens only when the pump is running. This acts as a control valve and also prevents unwanted flow or siphoning when the system is off. It helps to ensure Glycol only moves through the jacket when cooling is actually needed. If your fermenter has multiple probe locations, use the thermal well in the main body of the tank. This gives you the most representative reading of the overall fermentation temperature. The cone can respond differently and isn't always reflective of the bulk liquid. For cold crashing, simply lower your set point to your target temperature. For example, you might lower it to around 1 degree Celsius. The system will run more continuously until it reaches that temperature, which is normal behavior. To improve performance, keep your tubing runs short and avoid restrictions. Insulating your Glycol lines will maintain temperature and reduce load on the system.
Once you understand how this works, it's incredibly reliable. You'll get consistent fermentations, better control, and much cleaner results overall.